Yes, thank you. And thanks for being here today. It means a lot to me also. Thanks for giving me the opportunity to present here. We already mentioned the title, Can Crowd-Based User Ratings Against Misinformation Backfire? This is a project that I'm currently doing with Vincenz Frey, who's also with me at Groningen, and Arnout van der Rijt, who is a professor at EUI, but also involved with Utrecht University. Also quick disclaimer ahead. This is very much work in progress. An experiment will be conducted soon, or data will be collected soon. So I'm welcoming all kinds of feedback. Second disclaimer, what we're trying to do here, maybe also more in a more general sense, is to combine simulation modeling, experimental research, and that fit that together into maybe a bit of a more applied context, that is how to fight misinformation. Yes, that is exactly the background question of this study: how to alleviate the misinformation problem, more specifically misinformation on online social media. Or in other words, how can we stop people from subscribing to false information? So a traditional approach so far has been professional fact-checking, paying people to do that job. A problem with that is it is of course costly. It takes a lot of effort and time. And since traffic on online social media is growing exponentially, it is also a problem that this isn't very well upscalable. So an alternative to that has been proposed is algorithmic misinformation detection. The thing here is it is still quite an early and developing field. And second, it's not very transparent, or that's at least a common criticism on it. So therefore, both by the public and by the scientific community, we had some recent calls for essentially asking users to do the job for us through some sort of veracity rating, for example, where users, when they see something, piece of information, they can indicate whether they think it is true or false. The idea behind that is to achieve some sort of swarm intelligence. Why could it work? So in the literature, we know of this effect called the wisdom of the crowds. It basically rests on the idea that an individual might not be very good or very accurate at estimating something, but as long as you can assume that there are many individuals and they all have their individual errors, but these errors are essentially just normally distributed noise around a true value, you can just let many people rate, do their estimation, then aggregate, take an average, and this average will be very close to what the actual true value is. Of course, this is very suitable for estimation tasks that have an underlying continuous spectrum. Here we're talking about a binary rating task, true or false. So that's a bit different, but there is an adaptation of that as well. And that is, as long as we can assume that people are on average more likely to do a correct statement rather than a false statement, we can look at the majority of votes, and the majority will be with the accurate decision. And we can, of course, we can then use this knowledge. In wisdom of crowd tasks, people usually vote in independence, meaning they cannot see what other people did. This is maybe not so feasible for an online social network context, where, of course, we would like people to see what others thought and learn from that. Yeah, they would act under social influence, and as long as the influence that comes from the crowd is accurate, they can learn from that and themselves contribute to a rating by doing a correct rating choice, which will then further solidify a rating and influence others to do a correct estimation task. That's the idea behind it. Question is also of this paper, are there conditions under which it could backfire? And we argue, yes, that might sometimes be the case, especially in an online social network context. And that is because if you think about this rating and how it would develop, it would most likely develop along the path along which a message disseminates, right? As soon as people get exposed, they do their rating, the message travels further and so forth. The thing about online social networks, pretty much like all social networks, are clustered. They're clustered and they're homophilous, meaning people with certain traits cluster together. And these traits we can also look at in terms of systematic biases towards a certain kind of information. Now, if we take, for example, a polarized online community of conservatives and liberals, and there's a liberal cluster and a conservative cluster, and we launch a liberal false message in the liberal cluster, the liberals will be inclined to believe it, make an incorrect rating decision. This will then influence other users to make an incorrect rating decision themselves. And in the worst case, the rating then spills over to the other cluster and influences even more people to do incorrect rating decisions. This is clearly how it would then backfire. So the research question of this project is then how and under what conditions user-based content veracity ratings may hinder or amplify individuals' ability to correctly identify true over false information. Or in other terms, put simply, do ratings make people better at identifying misinformation? And if so, how and under what conditions? Two contributions. First, we expand on the conditions under which crowds may become wiser or not. And second, in a more applied kind of sense, we might be able to inform about the workings of a potential policy measure. Before I talk more about the precise predictions that we arrive at, I want to elaborate a little more on the setting. So we think of pieces of information that are either true or false. Of course, this is a bit of a simplifying assumption, but there we go. I will refer to them messages from now, and they have either a conservative or a liberal connotation. There's also the study plays in a conservative or liberal world, so to say. Yeah, an example of a message with a liberal connotation would be, for example, the one here on the right: affirmative action, students from public universities graduate with better grades and in more prestigious fields of study than regular students. This is, by the way, a falsehood. I will talk more about how we actually operationalize ground truth and falsehood later. Individuals are themselves either conservatives or liberals, and they make sequential rating decisions, where they then indicate whether they think something is true or false. And depending on whether the message itself is true or false, this can either be a correct or incorrect rating decision. With a sequential rating decision, we mean that a first person rates, their rating gets put into a rating, the next person sees what the person before that did, then the third person can see what the people before them thought, and so forth. Yeah. The intuition behind this liberals and conservatives and liberal and conservative messages is that liberals are more likely to find a liberal message true, and conservatives are more likely to find a conservative message true, regardless of the actual veracity of a message. Yeah, I would say this is what having a liberal or conservative bias means. Then we look at different kinds of rating sequences. I argue that each of these rating sequences has somewhat of a real world equivalent, or at least presents some sort of ideal typical scenario that we might be able to observe in reality. So the first one is one where no rating is available. This is pretty much the status quo on online social media, where we don't have a button that says, I think this is true or false. Yeah, we also call this the independence assumption, or the independence world, or the control world. Yeah, people are not under social influence from others. Then second condition is where liberals and conservatives alternate. So first a liberal gives a rating, then a conservative, then a liberal again, and so forth. It's a world in which there is perfect diversity, so to say. This is a bit about how previous studies dealing with these kinds of ratings and wisdom of the crowd scenarios dealt with, either by basically making sure that questions did not have a bias at all, or by randomizing the pool well enough so that there was no systematic correlation between rating order and the bias of people. And then the third one is the susceptible first world. This is so a world in which liberals rate liberal messages first before they get handed over to conservatives and vice versa. I argue that we can compare this scenario to an echo chamber online social network context, where we first have a liberal cluster where liberal messages originate, get rated first, and then get passed over to the other cluster, and vice versa. And then we compare these worlds and also compare how ratings developed within these worlds, essentially, depending on what kind of message we observe. For these ratings to work at all, and therefore also in order to make the study interesting at all, there is one condition, scope condition, that is necessary, and that is, on average, people must have a greater than 50% chance to make a correct judgment in independence, because otherwise the rating can only go wrong. Why is this? Because if people are more likely to make an incorrect than a correct decision, a rating will start off as incorrect. It will influence others to make incorrect decisions themselves. That will solidify the rating and further influence others to also make incorrect decisions. And yeah, therefore, we assume that this condition, that there is a greater than 50% chance to make a correct decision, is given. Yeah, this plot here also illustrates that. So basically what I did here is I built a simulation model in which I had a chain or a sequence of agents. And then on the x-axis, I have the difficulty of the message, DM. You can also read that in terms of how likely is an individual on average to get it wrong in independence, to make an incorrect judgment. And on the y-axis, I have the average accuracy of the entire sequence. That is how many percent of the people made a correct judgment. And the different lines represent different strengths of social influence. When there is no rating, there is no social influence. And then, yeah, the stronger the social influence, the more of an impact it plays for people, what people before them rated. And as you can see, as soon as we put the difficulty above 0.5, the rating backfires, because then people are more likely to make an incorrect judgment than a correct one, and the rating will tend to develop towards an increasingly incorrect signal. And this is expressed in the dashed line and the black line being below the dotted line if DM is greater than 0.5, and vice versa, the accuracy gets enhanced if it is below 0.5. So first prediction is then that ratings, you could also say allowing for social influence, enhances people's ability to correctly identify information if diversity is high. So if we're in an alternating sequence where liberals and conservatives take turns. Why is that? Because the sequence is alternating, the biases of liberals and conservatives cancel each other out. And since we have an average difficulty that is below 0.5, the rating will tend to be correct and positively influence others to make correct decisions themselves. Ratings will also enhance people's ability to correctly identify information if we're in a susceptible first chain and people rate true information. You can think of that in terms of liberals rating a liberal true information first. This means because they are liberals, they will be especially inclined to believe that the message is true. That way, the rating will be very unanimous, largely correct, and it will influence future liberals and then later conservatives alike to make a correct judgment themselves. In the plot, you can actually see how the difficulty can get quite high in such a case before there is actually an accuracy deteriorating effect, because of this added bonus of the liberal bias towards liberal true messages. The ratings, however, may also backfire and deteriorate people's ability to correctly identify information if susceptible people rate first and false information is rated. Yeah, think of, again, a liberal cluster rating false liberal information. Because they are liberals, they will think that the information is actually true, which will mean that the rating initially will be largely incorrect. This will then influence future individuals to make incorrect decisions themselves, and so forth, until the accuracy of individuals under social influence in this chain is much lower than as if they had been rating in independence. Of course, this only works if bias and difficulty is sufficiently strong. If we take a message that is very easy to guess and has only a very low bias, then it will not be enough to backfire, essentially. Even the liberals will still be able to identify the false information as false. Yeah, this also illustrates, again, how this backfiring then would work within one sequence, with i's position in the rating sequence on the x-axis. The dashed line is independence, where there is no social influence. The black line is such a susceptible first chain. You can see how accuracy goes down among those who are susceptible to this false information. And then even for the ones who are not aligning with the political connotation of the message, their accuracy will, because of this largely incorrect signal, have also a much lower accuracy than individuals rating in independence. Put simply, ratings usually enhance individual accuracy, but when susceptible individuals rate bias, false information in first, it backfires. We'll talk about how we plan to test this experimentally a bit now. So we first recruit an equal number of liberal and conservative subjects on Amazon Mechanical Turk, so a crowd working platform in which we can easily place an advertisement, also called a human intelligence task. And we have the option there to filter in advance to say only people who indicated that they have a liberal ideology can participate here. Only conservatives can participate here. And then they click on a link and arrive on our experimental platform. And there we check if their own self-identification, their ideological self-identification, really matches with what data has been put in there on Amazon Mechanical Turk. We then divide them up equally in three conditions, pretty much as I outlined above, in independent sequences, alternating sequences, and susceptible first sequences, where liberals rate liberal information first and conservatives conservative information first before it gets passed on to the other group. We then take our informational messages. That is a set of 20 messages in total. They are either true or false, and they have either a liberal or conservative connotation. And we operationalize that by basically browsing through social science and general science journals for a while, then selecting articles where the central finding in our perception had somewhat of a political connotation or a political implication. And then we took out the central finding in one sentence, or we wrote it out in approximately the length of one tweet. And this was then a groundly truth message, grounded truth. Yeah, for a false message, we took another central finding, we inverted it, and that was then the ground falsehood. Next step was that we pre-tested extensively to ensure that the ideological bias was really worked as intended. In other words, that a liberal message would also be more likely to be perceived as true by liberals than by conservatives, and vice versa. And that on average, people were more likely to get it right than to get it wrong to fulfill this scope condition. Yes, this is an example of a liberal falsehood from our set, and a screenshot of the subject experience, right, where you have an indication of what others said before and your own choice to click true or false. This is the message set. what is maybe relevant here is that we have the set of 20 messages, and that it is very symmetrical. So there are 10 true and 10 false messages, and 10 conservative and 10 liberal messages, and of each combination there are 5. Of course, we don't run each sequence only once for each condition, but actually 20 sequences for each condition to have a couple of independent observations. If we only did it once, then it might as well have been chance that accuracy in a certain condition developed in a certain way, and we wouldn't be able to really pin it down to our stimulus. Each session consists of exactly 25 liberals and 25 conservatives, and depending on in what condition they're in, we vary in which order they are rating. When individuals arrive on our platform, we start many sequences in parallel so that we can host a large number of individuals and then continuously work ourselves through the subject pool. There is a $1.50 flat fee endowment for the task, which should approximately take 5 minutes per individual. This whole setup has been granted IRB approval before. We are yet to pre-register hypotheses and so forth, but this will come soon. Yes, and we're aiming at starting data collection within a few weeks, most likely. As for the planned analysis, so once we get all our data back, we can compute the message parameters from the independence condition. So how difficult was a message, and how strongly biased was a message. And then for each sequence, especially for the sequences under social influence, we can compute the average accuracy for all individuals per sequence. How many percent got it right? And then we can compare this accuracy with people's accuracy in independence. Whereas again, the expectation is that in an alternating sequence, the accuracy goes up for true and false messages alike. Whereas in a susceptible first sequence, the accuracy goes down if the message is difficult and biased enough for that. These are three discussion points that we're currently still pondering about, and that might also be interesting to discuss with you. One is that we're thinking whether it might be useful to also introduce a continuous rating condition. So where individuals, instead of doing a binary rating, can indicate a certainty of how certain they are that the message is true or false. My expectation there is that this might not change a lot, but to render effect sizes not as large. But I'm happy to discuss this. Another one is the $1.50 flat fee endowment a good way, or should we incentivize people to make correct decisions only? This has pros and cons, in my opinion. An advantage is, of course, that we will prevent people or de-incentivize people to just make random choices and to click around. On the other hand, incentivizing people may also crowd out their biases. Yeah, so when they get incentivized, they do not think of these messages in terms of their own ideology and the ideological connotation of the message, but really just very hard whether it is true or false. And I don't think that this is how it works at all on online social media, and also not that we would just get there with a veracity rating that is, voluntarily to participate in or not. So by incentivizing people, we might first crowd out our own effects, and second, then also not really measure something that could be implemented as such in the real world. And the third one is an open question. mTurk is one of many crowd working platforms. We have entertained the idea of using prolific instead, but the pool of conservatives is very small there. I'm happy to discuss alternatives if there are any suggestions. Yeah, that's it so far. Thanks so much.
Thank you very much for your presentation. Milena, if you would like to go ahead. Your presentation, there you go.
Yes, yes, I'm ready to go. So thank you so much, Jonas. It was a pleasure to read the paper. So I did request to read a paper. So actually, I'll have more formulas in my presentation than you gave us. But I also actually was happy to be assigned this paper because Vincenz and Arnout's management science paper, which this is kind of a extension of, has been sitting on my desk for a while. So this was a great opportunity to, to finally read it. All right, so let me get started. So I just wanted to start with kind of just situating the research here. And I want to congratulate you on actually kind of finding this unique nexus of a lot of actually hot and very pertinent topics these days. So my understanding of your work is that what you're trying to do here is that you're looking at sequential decision making and social influence combined. So basically making decisions sequentially, but then also having information from what others have done. And once we interacted with homophily, the fact that we are embedded in networks where our social circles usually constitute of similar others, that when we combine these two phenomena, we actually get something that deviates from the wisdom of the crowd, which is what a lot of previous research has pointed out. So as I mentioned, this kind of actually outlines like 3 different fields here. So first, sequential decision making and social influence is an area that, or rather, the kind of phenomena have been studied in the context of information cascades and cumulative advantage. So that, of course, has been mainly in the context of, say, cultural markets or influence of ratings and online particularly, for example. But obviously, it's also very relevant here anytime you have an online interaction where multiple individuals make decisions with information what others have done. Homophily is, at least in the context in which you're looking at, this is a kind of a phenomenon that's currently very much studied from the point of view regarding political polarization and echo chambers. So that's kind of the relevance of where your research is situated. And of course, wisdom of the crowds is kind of a huge area of research that has been kind of in more abstract terms looked at. But what you do, and I think this is quite interesting, and also the kind of the implications here, the practical implications are almost unusual for a lot of experimental research, but they're actually very very palpable here. So you kind of embed it in this context of fake news or misinformation, and also actually algorithmic bias in a sense, right? Or kind of, I think it also has implications regarding how do we design algorithms that might be able to correct for these biases that come from the procedure, but also social phenomena such as sequential decision-making and homophily. So we have like 4 super hot topics here, all combined in one with the very practical implications. So, congratulations, I see a great career ahead of you. So this is really, really impressive, I must say. That I really like how this is kind of combining topics, the very different research, but all coming together. Now, I also want to, as someone who does experiments, really congratulate you on the very clever experimental design. So I know this is kind of an iteration of what previously has been done, but for others, I want to point out I think there are a lot of challenges of doing large group experiments online. And what the authors do here is that you guys, so you have asynchronous interaction. So as you mentioned, you have these multiple chains that are running simultaneously, and you have kind of individuals being assigned to the next available chain. And so that reduces waiting times, right? You don't have to you usually have these periods of where you have to wait for everybody to make decisions so that you went. So just this whole flexibility of assigning and running chains simultaneously, it's pretty cool. And the other, I think, huge improvement here is the fact that you have been in the past, and I think probably for this project too, do this kind of on-the-go or real-time removal of low-quality responses. So I didn't mention this, but the idea from what I read is that if you would use so a way of detecting it in terms of how much time someone takes to make their decision. So if it's too short, obviously they haven't read the statement or thought about it enough, or if it's too long, it means that maybe they were Googling and searching this. And so once they give this response, you would remove them from the analysis, or rather from the real-time experiment, so that they're biased in different ways than the ones you're studying, but they're basically, their low-quality response would not be affecting the individuals afterwards. And so I think this is very, very smart, because often with this kind of group-level experiments, the problem is, what do you do when you have a rogue participant in the middle of your chain? Do you scrap the whole chain? Do you stop analyzing at that point? And obviously scrapping the whole data, like 50 individuals because of one, it's very painful, right, when it comes to budgets. So I think that that's really great kind of innovation, and I think it's very attuned to basically online research and the problems we're having there. Now, so I realize this is work in progress, so I had some kind of discussion points. They're not necessarily things that need to be changed, but I think it's more of things that you should be aware that might be raised kind of as potential problems. So, okay, so my first comment is that, and of course this is not necessarily something bad, but my impression, so here are the formulas that I mentioned, is that the model you present is a prediction model, but it's not a behavioral model. So what I mean by that is that it does not model how decisions are actually made. It just tries to predict the probability of making a right decision. Now, while technically there's nothing wrong with that at all, I think that actually it does point out some other problems that might be related to this fact. Okay, so I have a bit more information than what Jonas presented, but basically the model tries to predict the probability of being correct as a function of a person's difficulty, so the individual difficulty of guessing correctly, which itself is a function of the bias, so how, whether it's skeptical or susceptible to the information you have, whether the message is true or false, and then some kind of message properties that were already mentioned of the likelihood of how biased this message is in general in the independence condition, and how difficult it is to guess it correctly. And then, so this is the individual difficulty. And then we have also, of course, the susceptibility to social influence and the rating signal. So that is a function of previous guesses. So right, that's where the sequential element comes in, is that you have this, when you're making your probability of guessing correctly, depends not only on how you personally find how biased you are or how personally find this message difficult, but also on the how well others have done. Now, as I mentioned, there is the different approaches. This is more of a prediction model rather than behavioral, so it's not based on kind of cognitive processes. But I think what I was missing in the very initial draft that I saw was kind of linking these processes to well-known behavioral mechanisms or social mechanisms. So, for example, I would kind of in tradition of social psychology, of course, you can decide to go some other way. But I would call this conformity bias, right? And that's, of course, in reference to what the rest is, which is this bias about liberals being more likely to guess correctly liberal true messages. So that's confirmation bias, right? So your paper didn't really make kind of reference to this. And I think there is a huge kind of literature regarding this. And I think you'll benefit a lot from bringing in and kind of discussing, incorporating some of the findings, right? So a lot of this has been studied in very different contexts, of course, with deception or right, like with different methods, like survey methods and so on. But I think that there could be quite interesting insights, and I hope to actually illustrate some of these. So I would kind of encourage you to think more about the mechanisms, and although you don't necessarily have to kind of redo, reconceptualize the models to make it a behavior model, I think that kind of linking to behaviors would be quite useful, both to kind of comprehend what is happening here, but also for some insights possibly that might be affecting your analysis or even the design. So now this is, I mean, these are all kind of related to each other, but the other thing that I was kind of missing is that a lot of the assumptions in the model that you have were quite implicit. So this is my attempt to, so it's a quite complex model and experiment in a sense, right? Because you have two types of individual, liberals and conservative, and then you have statements that could be both liberally biased and conservatively biased, and they can be both true liberal, false liberal, true conservatively biased, false conservatively biased, right? So it's quite kind of hard to grasp, but that was my attempt to kind of to summarize of how the difficulty of the message and the bias would affect your likelihood to the individual difficulty. So basically how affect your likelihood to be correct. Now, there are some assumptions here that are not explicitly stated currently, and I think they might point to ways either to modify the model, test it for robustness to these assumptions, or to kind of extend the analysis later. So one of the assumptions is that you assume the same confirmation bias for liberals and conservatives, right? So basically, liberals and conservatives are equally likely to sway one way or another, or to give in to their desire to have their political views confirmed. Now, you also have the same confirmation bias for congruent and incongruent statements. So statements which you agree with or you don't. And then you have also this assumption that there is a symmetrical confirmation bias for true and false statements. So kind of the sway either way is the same. Now, this is pretty similar when it comes to conformity bias. So you kind of assume that liberals and conservatives are equally likely to be influenced by others' opinions. They're equally likely to be influenced regardless of whether these are messages that they agree with or disagree with, or even regardless of whether these are true or false statements. Now, regarding the true and false statements, I mean, I'm kind of naming things here, very frivolously, but, let's call it authority bias, right? So you're giving them statements. And so I think in general, there could be this, and they sound kind of very factual, right? So there could be this tendency to trust factual statements. Now, I understand from the design you have, this should not be a problem, right? Because you have this kind of baseline condition that would be measuring this, that's the DM. But I think it's also kind of, it might be important to emphasize to what extent these are assumptions that affect your model or not. Now, the other possible other situation you might have is that one group, so either liberals or conservatives, may be less susceptible to one of the biases. So they might be less susceptible to confirmation bias or less susceptible to peer pressure, social influence. Now, actually, just to reveal my own political bias, so I assume that's true. Then I did a very brief, Google search. And from what I saw is that previous research has shown that liberals and conservatives have equal confirmation bias, basically. So there isn't, so you might think that liberals are, say, for example, more kind of self-critical. That was my bias, but that's not necessarily the case, right? So I think like drawing on this literature to, again, emphasize why this shouldn't be a problem for your model, or you don't even need to address this, or why, if that's not really as the case, why you need to consider it, or again, not, because it actually doesn't change the model prediction. So I think that will be quite useful. And then of course, conformity. So the kind of the likelihood to be influenced by others, I think might vary for statement, for messages that you agree with or not, right? So the model makes all these assumptions that these are pretty much static, but I think these parameters themselves might actually be interdependent in a sense. Now another point I wanted to raise is that, and this is something that is is not in the model, but it's actually in the design of the experiment, is that in the model, your rating signal, so kind of the information you get from others, so the source of social influence is expressed as a kind of a function, like a fraction of the previous correct rating choices. So in a sense, I does not play a role here, so you just get a proportion. While in the experiments, you're planning to show, even the examples you gave us, you're planning to show I. So I being the position of the person who's making a decision in the chain. And so you showed us this figure where you expect this kind of huge discontinuous effect of the first, say, skeptical individual. But I'm just, I'm just very skeptical that this is what was going to happen in reality, because if I see that 45 individuals have rated something as false, and now it's and 5 as true, and now it's my turn to do it, I would say that social influence will be way stronger than my confirmation bias, right? Than in another situation where I might see 5 individuals rating it as true and say 1 as false, right? So, and this is also surprising to me because, as I mentioned, the paper that is kind of is an extension of did find indeed that that absolute number of votes mattered, right? And so if, and again, linking back to what I mentioned about that this is a prediction, but not really a behavioral model, is that you are not really modeling the information that individuals have or how they judge it. And in this case, you're giving them I, so the order in which how many others have before them have made this decision. And so I think this will make a difference. So I think it's, and again, one option would be to just show why it doesn't change the predictions, but it's just something to address if indeed it doesn't change the predictions. Now, finally, I'm glad you also brought this up about the incentives, because I also kind of, raised my eyebrows when I was reading it. So you made a statement about how that you think that giving participants a flat incentive, so basically flat payment, would make it more truthful, so kind of more realistic in the situations they're facing. And I wondered, after reading kind of the previous paper by Vincenz and Arnout, I had this suspicion that they faced a lot of reviewer critique regarding the incentives they used in the experiment. So originally the experiment, my understanding of the paper was that they used a mix of group and individual incentives. So your payment depended on the accuracy of the group, but also your own, whether your own choice was accurate. And so then they had to, again, that's my interpretation. You probably, Jonas, have more information about it. But my interpretation from the paper was that probably reviewers asked them to do this again with only individual incentives, or they realized it, of course, at some point. And so indeed, they found that the group, so once you remove the group incentives, the social influence effect gets weaker. Now, that's again something to, it looks like this is no longer an option even to have group incentives. You are aware very much of the noise on MTurk and the problem of not incentivizing people, and I think that there might be an issue here that you might not be even able to capture with the threshold you have in terms of how much time they spend. I think that they can still spend due time, but just not care about the result in a sense, right? Like not even think carefully. But I also think that I think there's no right answer here in terms of which incentives are best. I think they basically model different kinds of interaction situations. And so my advice would be, and of course that's the worst advice in terms of experimental budgets, but to basically have two versions of the experiment and to kind of look at, I think that if there is a flat rate, we can think here of low stakes information, and if there is obviously incentive to be personally correct, you can think of this as high stakes information. So for example, low stakes information would be some gossip about a politician, right? That doesn't really necessarily personally affect you, but high stakes information could be, say, vaccination information, right? That's something that actually affects your choice, and you want to be correct, right? Like that you judging a statement might make you correct. And then, of course, in the other paper, there was the group incentives of where it was more framed about kind of institutional environments and like team groups and so on, right? So that would be kind of my own suggestion, that I think that this is not, it is a point that cannot be won and cannot be resolved. And so I think you have to kind of think of it as basically work with it in the sense of modeling different decision situations. And obviously, high stakes information, then the social influence will not be as strong. But then it'll be interesting to see how personal confirmation bias might be affecting. Okay, so with that, I think that was my last comment. So thank you very much. It was a pleasure to read this, and I really look forward to where this work is going.